Welcome to the second installment in my build FAQ videos. Right, this one we're going to focus on power transformers. How to choose a power transformer to match the kind of build that you're contemplating undertaking using one of my PCBs. First off, the power transformer. This is a 50 watter. Right, it has primary winds and secondary winds. The first thing you need to make sure is that your primary winds will match the wall voltage in your country, right? Many of them, most of them, will do everything from 100 to 240 volts, but some of them don't, right? Some of them are hardwired for 120 or 240 or something else, right? So always check that. The first thing you want to decide about your build is what wattage you're going for, right? I often get asked questions, can you send me a 50 watt board or a 25 watt board or a 100 watt board? They're all the same, okay? The way that these are set up is that you can configure the rectifier section on the PCB to suit the power transformer that you've got. All right, so this video will deal with how to set that up, right? But first thing you need to decide is, are you building a 20 watt, 25, 50 or 100, right? But that'll narrow your choice down straight away. Bear in mind that most of my boards are Marshall kind of inspired or in that Marshall kind of territory. So any kind of standard Marshall set, you're 90% of the way there already by going and looking at a Marshall style replacement set. The next thing you're going to want to figure out is what high voltage secondaries to go with, right? So we'll have a look at some transformer spec sheets in this video and kind of walk through the basics of how to kind of read that and how to interpret it, and then how to figure out what your plate voltage is going to be. Because if you've decided on a 20 watt build using 6v6 tubes, you might be thinking, look, I'm probably going to want about maybe 400, 420 volts. On the other hand, if you're doing a 100 watt EL34, you might be looking for 480, 490 volts on the plates, right? And knowing how to read these spec sheets and understanding the difference between a full bridge rectifier and a two-phase rectifier, and how to then use the spec sheet to figure out what your plate voltage is going to be, that's really the trick. I've got 3 boards here, all right? Let's deal with one of these first. This is kind of one of the larger ones. This is our 4-gain stage generic, but the MC2, the MTL, the Cali, the standard Marshall board, it's kind of those larger boards that are set up to do up to 100 watt builds. They all have the same rectifier set up. All right, so I'll put this up on screen now, and I'll detail how this is set up on the PCB. And when we look at the difference between two-phase rectification and full bridge rectification, we'll be able to understand how to set this up. When choosing a power transformer to use with one of my PCBs, you need to understand the difference between two-phase and full bridge rectification, right? So we're going to have a look at that very quickly, because with that understanding, you'll be able to quickly move into selecting the power transformer that's most suitable for your build. All right, so on screen here, this is two-phase rectification, right? And it's very common in 50 watt amps and below. This type of rectification that you would use when you've got a center tap. All right, so this is our power transformer here. So this is where your mains would come in on this side, the primary side. This is the secondary side. And if your high voltage secondary has a center tap, then this is often how you would wire it up, right? So you got basically 2 diodes running together to give you your B plus voltage here. Here's the mains filter cap, and you've got it set to ground. Just want to give credit to the Valve Wizard website, which is where these schematics have come from. Again, I've mentioned it before, there's some fantastic information on that site, including the basics of rectification that I'm talking about right now. So this is a full bridge rectifier, right? It uses 4 diodes, and this is the style of setup that you would use when there's no center tap. Right, there's no center tap on the secondary of the power transformer, the high voltage secondary. Okay, this is very common in 100 watt amps. Rule of thumb, center tapped, as we were just seeing, probably 50 watts and below. Non-center tap setup like this with a full bridge rectifier, probably 100 watts. And just to confuse things, here's a setup with a full bridge rectifier and a center tap. This was very common in early Marshall 100 watt amps, right? So yeah, you can use a center tapped secondary, high voltage secondary on your power transformer in a full bridge setup. And what you do with your center tap is you set it in between. This is why you see in the Marshall 100 watt amps, you'll see the can caps, in a 1959 Super Lead or an early 2203. You'll see on the mains supply, on the mains filter cap, screens as well, but on the mains filter cap, 2 can caps in series. And the reason for that is because they're tapping off the center tap here, and it goes in between. Okay, what you're getting here basically is a voltage doubler setup, and what you'll normally see in one of those Marshall amps, you won't see ground in the middle. You'll see ground set to this thing here, and you end up with double the plate voltage with this setup. So let's look at some old Marshall schematics to see this at work, right? This is a very early drawing of a 2203 circuit, right? JMP era this would be, but you can see this is the master volume 2203 with a high and low input. Let's get straight to the power transformer. Here it is right here. Okay, so primary side here, this is our wall voltage, right? You select all these different wall voltages. This is the tap, the secondary tap that we're interested in. This is the high voltage secondary. And you can see, right, standby switch, right, double pole, double throw. So it's got two poles that'll throw. So when you flick that standby on, you're going to get this high voltage secondary applied to this full bridge rectifier here. I know the drawing's a bit, not overly clear, right? But 4 diodes and a full bridge rectification setup with this point here grounded. Now, look at what's happening with the center tap. All right, the center tap comes up here, sits in the middle of the 2 filter caps, the 2 mains filter caps that are in series, right, that then sit on ground, right, chassis ground, right. So here's the ground point, here's the ground line, ground, 1 cap, center tap in the middle, another cap, and then here's our high voltage line, right. So at this point here, you've actually set up your B plus line, because you can see through the HT fuse that is coming into the center of your primary of the output transformer. Here's a 1987 circuit, a 50 watter from 1968. All right, fantastic schematic, this one. You can see this is as a 50 watt amp. Here's our 2-phase rectifier set up. All right, again, power transformer, primary voltages here. Here's our high voltage secondary, this one right here. And you can see the diodes are pointing in the same direction. The reason they have 2 is just for safety, right? So if one of these fails, you've kind of got another diode there. You only actually need 1 to make the circuit function. These are just kind of redundant, right? You can see they're pointing in the same direction. Cathode and anode are pointed back to back. So as per that schematic, very simple schematic that we were looking at from the Valve Wizard website, you can see in the 2-phase setup, these guys come together here, and here's our B plus line set up, and mains filter caps right here, right, just a bridge 240 microfarad in this example. Center tap. Center tap is set straight to ground. So let's have a look at some power transformer spec sheets, right? So how do you translate all of that into, you know, choosing something, right? So you browse around on the internet, and you see the specs for these things, and you go, well, okay, so what does that tell me? This is NIC's at Seriatone, right? This is NIC's 100 watt AH power transformer. This is a good transformer, this one. I like it for a couple of reasons. It's quiet, it doesn't hum. It's got this tap on it here, which is great for relay supplies. I'm going to talk about that separately. So let's focus on how to kind of interpret this thing with respect to our high voltage secondary and the plate voltage. So here it is here. All right, what does it tell you? 180 volts, 0, 180. So this is 360. All right, 360 from purple to purple, 360 AC at 0.4 of an amp. All right, 360. Here is a Haber 100 watt PT. This is a fantastic power transformer. It's available on the Amp Parts Direct website, although at the moment, as I sit here in January of 2022, it's sold out. But I've used this PT quite a few times actually. I like it. A couple of reasons, right? Solid PT. It's got 600 milliamps of current availability here on the secondary, which is awesome. It has the same secondary here, secondary tap for supplying a relay supply for and also for DC heaters. Again, we'll talk about that separately. Here's our high voltage line. All right, red to red is 350. Okay, so the previous one was 360 at 400. This is 350 at 600. This one actually has more power capability. And last but not least, here's an old classic tone spec sheet. All right, so gee, I miss these transformers. I wish these guys were still in business. Used this PT myself a bunch of times for 50 watt builds. I liked this because you could choose up to a 710. So again, here's our configuration. Power transformer here. Set this up for the primary side for your voltage. On this side, secondaries. So let's have a look at the secondary high voltage here, right? 710 or 610 center tapped at 200 milliamps. The center tap is this red and yellow one right here. Okay, so on the outside, red and red, we're going to have 710 from pole to pole, right? So that's 355 per side, 355 from center tap to outside, center tap to outside. It's got a 610 tap as well. So red and white to red and white is going to be 610, also center tap. So this is perfectly set up for a 50 watt two-phase style build. Right, so now that we've had a look at the difference between two-phase and full bridge, let's have a look at how you would configure the rectifier section in one of these main boards. Here's the PCB layout for our 4 gain stage generic board, right? So I'm just going to zoom in on this and we're going to have a look at the rectifier section here. Okay, so here we go. Here we've got 4 diodes. So as I mentioned, the way that I do these boards, you can set up these 4 diodes here, 1, 2, 3, 4 as numbered, in all of the ways, all of the 3 ways actually that I identified in this video, right? So for two-phase setup, what you're going to do is you'll bring your high voltage secondaries into these pads. All right, one here and one here. Then you run up diode 1 and then diode 2. Remember, we saw that in a two-phase setup, you can still use 4 diodes. You run them in the same link like this, right? And your other high voltage secondary will come in here. You've got your 1N 4007 here and 1N 4007 here, and you're done, right? Scenario 2 is full bridge rectification. Okay, so your 4 diodes go in here the same way. This time though, your high voltage secondaries are going to come in here, right, in the middle. One goes here, one goes here, and then in a full bridge setup, you need to ground the base. Okay, so on these boards, and all of them are set up like this, with the exception of the Mini and the double Shirley. I have ground pads right here, right? So you just link these, link that to that, and then bang down to there, set it to ground. You've now got yourself a bridge rectifier set up with your high voltages coming in here. And we also talked about a bridge rectifier set up with a center tap, and that's what this pad here is, CT. Okay, so ground those high voltage secondaries in here, and the center tap for your 100 watt build sitting right here, which is, as you can see, is the midpoint between, this is your 2 mains filter caps. Easy as that. I did mention that there were 2 boards that I have in the lineup that don't have that type of flexibility in the rectifier section. The first one is the Mini, this one. Right, the Mini is set up for 2-phase only. It's kind of set up to do, you know, 20, 25 watt, 18 watt, up to 50 perhaps, right? You can do a 50 watt EL34 build with this, but all of those are going to be set up with a center tap secondary in 2-phase. There is a hack that you can put into this very simply, actually. If your power transformer does not have a center tap on the secondary, and I do have that detailed in the documentation folder if you need it. This one here is the double Shirley board, which is, you know, kind of 2-channel Shirley. It's a JTM 45 style power section. As you probably know, it's tube rectified. There are no diode rectification on the board, so you won't find this setup on here. In part 1, I talked about one of the reasons why you would go with a PCB based approach to building, right? And that is primarily that you can, you know, the PCB will handle the complexity associated with switching options, channel switching, boost switching, so on and so forth, right? It's all achieved with relays on the board. Now the relays need a DC supply. So one thing that you need to consider over and above a kind of standard power transformer setup is how you're going to get a low voltage AC supply to set up a DC supply for your relays, right? There's 2 ways to do this. Number 1 is you find a power transformer that has a low voltage wind already on it that you can use for that purpose. Now, I do not recommend using your heater supply for it. You get into grounding problems with that. It can be done, but I don't recommend it, right? Some power transformers have an additional low voltage wind, sometimes a 5-volt wind that's used for a tube rectifier, or maybe an additional 6.3 volt AC wind, and those can be used to set up a DC supply for 5-volt relays, right? Other power transformers, like this one here, which is a custom wind for me, actually has a 15-volt AC 2-amp secondary tap on it, like a couple of the PT specs that I've shown here. A 2-amp supply like that at 15 volts AC can be rectified on the board using the heatsink here with a voltage regulator for a 12-volt DC supply. The reason you want to do that is, well, you'd have 12-volt relays, nice, you know, whatever. But the real reason is you can do 12-volt DC heaters. I did a separate video on setting up DC heaters in a Marshall amp and why you would do it, and the benefits of that. So these main boards have all of that already built in. You do not need to buy a separate DC heater board from me if you're doing one of these builds. The alternative to having a secondary high current wind on your power transformer that can power both 12-volt relays and DC heaters, 12-volt DC heaters, is to get something like this, right? This is the Hammond, as you can see. This is a low voltage but relatively high current. It'll supply up to 2 amps, right? You see here, right? 14 volt secondary at 2 amps. And you can wire this guy in 2 different configurations on the primary, right? So, you know, if you're 120 volts at your wall, you'd wire it like this. And if you're in, you know, the UK, Europe, Australia, New Zealand, you'd wire it like this. Hammond also have one of these, I think it's a 166 L14, which is set up just for 117 volts AC. You know, so you don't have to worry about kind of wiring the primary separately, and it'll also do 14 volts at 2 amps. So this is a perfect kind of little power transformer that will mount into the inside wall of your chassis. And if you're just looking for a very small power transformer that will simply be used to power relays, then you can use something like this. I've actually used this exact little transformer here, right? It only does 150 milliamps. It's tiny, but if you're just powering a handful of relays, this is fine, right? You run this into your voltage regulator, get yourself a 5 volt DC supply and use 5 volt relays, and you're cooking with gas. It's probably worth just mentioning chokes as well, right? So, you know, let's call the choke as part of the power supply section. Do you need a choke? Well, I think any amp will benefit from a choke. It's optional in, you know, 25 watt builds and less. So if you're doing a EL84 or a 6v6 style amp, you get away without a choke. Just use a fixed resistor instead. But I would. I mean, I've done a couple of 6v6 amps that I've kept for myself, and they've benefited from having a choke. And with respect to choosing the choke, just kind of follow, you know, the Marshall spec, right? So somewhere in the 3 to 5 Henry region, I think works really well. So, for example, if you're building a 50 watt, you know, amp, a 50 watt Cali, right? Use as an example. The Cali it's a Jose, right? It's a modded Marshall. Go for a 50 watt JMP spec. Have a look at, you know, the Marshall schematics for that. If you're in doubt, post a question on our DIY builders group, and myself and others will jump on it. Let's go hunting for power transformers. All right, so there are obviously a bunch of amp supply websites that you can go hunting around in, you know, in your local country, local region. I'm using the Mojotone site just for the purposes of this clip, because I just like the way that they've kind of set these out here. It makes it pretty easy to, you know, demonstrate what I want to take us through in this section of the clip. Right, so here I am. I've filtered on power transformers. I'm going to look at British, which is obviously our Marshall amps, and we're going to look at these three, right? Because across this 18 watt, 50 watt, and 100 watt, we're going to cover the different styles of setup, two-phase and full bridge rectification that we've already talked about, and we'll also cover the rule of thumb that we use to estimate what our plate voltage would be using each of these, right? So let's have a look at this 18 watt to begin with. Bring up the spec sheet. All right, so let's have a look at this. So I've obviously got a primary side and a secondary side. What I want us to focus on here is this 290 volts at the top here, right? So red, yellow center tap, and red again, right? So this is actually from one high voltage secondary to the other. It's 580 volts, right? So 2 times 290. When you're setting up a center tapped high voltage secondary like this, it would be for two phase, right? We've talked about this, right? So, you know, for a secondary like this that is center tapped, I mentioned already, right? Typically 50 watts and below, you'll see it like this. The rule of thumb to estimating what your plate voltage is going to be is to use just one side, the voltage on one of these coils here, and they've already shown it here, right? It's 290. Multiply that by 1.3. Right, so that's 377 volts. Now that's a conservative estimate, right? So what we're doing there is we're, taking an AC voltage to 290 and using the 1.3 to get to a DC voltage. Like if there was, in the perfect world, it would be times 1.414. But in the real world, you've got to use, 1.3 is a very conservative number. Like sometimes you can go 1.35 or you'll get 1.35, it depends on a bunch of things around the, how you've got your amp biased and what tubes you're using and so on, right? So if I take 290 by 1.35, I'm going to get 390 volts. But you can see you've got a range to use there, right? It gives you a pretty tight range where you know that your plate voltage, if you use this power transformer, what it will be predicted to be. Let's move to the 50 watter. Let's have a look at this one. Here's our spec sheet. Now, and you can see in this spec sheet here, they've actually spelt it out, a bit clearer, I guess, with respect to the, the 360 on either side of that center tap. So this power transformer, from one high voltage secondary to the other, red to red, 720 volts, pretty healthy, right? So using our rule of thumb, we're going to take 360 multiplied by 1.3. It's 468 volts DC on the plates, which for a 50 watt plexi I think is pretty much perfect. As I said, you might get a little bit higher than that, but that's pretty fair estimate of what you're going to get. So let's finally have a look at the 100 watter. Here it is. First thing you'll notice is how different the voltages are, much lower. All right, this can be confusing for people. They go, well, hang on, I thought this was a 100 watt amp. Why are my voltages on my secondaries here so much lower? It's because this power transformer is set up to be wired in full bridge rectification. All right, the previous two we looked at were two-phase. So what we're going to do with full bridge is you need to take the voltage, to use our rule of thumb to estimate what your plate voltage will be when you wire this in full bridge rectification mode. You need to take the voltage, from blue to grey, right? So that the outer coil. So 178 times 2 is 356, right? Take our 356, multiply that by 1.3. 463 volts DC plate voltage, which, for a 100 watt plexi, I reckon is pretty perfect. So you might have noticed that for each of these three power transformers here, none of them had a suitable low voltage secondary wind to power relays and DC heaters, right, as already discussed. And this is where, if you're grabbing one of these kind of off-the-shelf drop-in replacement power transformers for Marshalls, this is where getting one of those small auxiliary power transformers, which I've already spoken about, is a perfect option. And finally, let's just talk about suitability of these for each of the different type of boards that we have, right? So this 18 watt PT here, this was set up for the Marshall 1974 amp, which is an 18 watt EL84 powered amp. I mean, Marshall still have it available as a reissue amp, right? The 1974X. This is a perfect power transformer to use for the mini board, particularly if you're doing a mini with EL84 tubes, right? Absolutely perfect. In fact, this is the one to get. You can use this 18 watt even if you're doing 6v6. In fact, one of the 6v6 powered mini builds that I did for a local player, we used an 18 watt PT that he already had, and it came out great, right? Even in 6v6 modes, perfect. So really good for that. Moving to the 50 watts. Now this is a perfect PT to use for anything we've got in our 50 watt range, right? So the Kelly board in a 50 watt mode. Obviously the Marshall ST1 board, which is set up for 2203, 2204 JMPs or whatever, right? Also the MC2 and the MTL, perfect PT for that kind of thing, right? As I said, notwithstanding that any of these, you need to get the kind of the secondary smaller PT for your relays. And finally, if you're doing a 100 watt build, then something like this is again perfect for, you know, if you're doing a 100 watt Kelly, the MC2 or the MTL, they'll all work perfectly fine with this style of PT. Well, that's it for today's clip, guys. I hope it's been useful. Next one will be on output transformers.